وعليكم السلام حبيبيز wagwan yelikunanis. Hey, check this. Man woke up early morning and man had to practice some kung fu. Cause the sun's out today, so I might see a pagan trying to catch a little tan. So I'm have to back up my nunchucks and do a little buck flip and spin it across man's skull. Now I'm joking, we don't condone in violence. We only condoning the mechanics. So let's jump straight into this. A little light work thing as usual. Man's gonna take difficult and make it simplification. So give me a sec. Let me drink a little something. Okay. Okay, a little something to get me started. So, now, listen, before I get started with this this topic, there's one thing you lot need to know. So, you lot need to go and watch my previous video, intro to pulleys. Okay, so go watch that one. If you haven't watched that one, go watch that one and then come back to this one. Okay, because I'm not gonna be explaining too many things again and again. Cause man ain't got energized. You get me, fam? Man's low on energized right now. So give me a sec. Let me just get ready. All right, cool. Let's get started. So remember, go watch that video then come back. All right, now there's a few things we need to know. So looking at the top right here, it says the plane is not smooth, so therefore there is friction. Okay, now by the plane, they're talking about this thing here. Okay, so remember, yeah, listen. You see when you're running, why do you get tired? That's a question you need to ask yourself. The reason you get tired is because on this planet, okay, on the concrete, there's something called friction. So when you're running forward, the concrete is pushing you back. You get me? There's friction pushing you backwards. That's why you get tired. You get me? So when the plane is not smooth, it's like real life. So there's friction. Okay, cool. And it also says the string is inextensible. So the string inextensible, if you remember, so if you have watched the last video, if the string is inextensible, basically what that means is, so remember, this is the pulley, yeah? Now when you've got a pulley and the string is inextensible, that means the tension towards the pulley is equal. So this T here is equal to this T here. Remember that, okay? I'm going to explain this one more time. So the string is inextensible. So this is the pulley, okay? And these are the strings, okay? If the string is inextensible, the tension goes towards the pulley. So therefore, the tension goes towards the pulley and they're both equal. So this T here is equal to this T here. Come, little light work thing. Now, okay, cool. So we got that started. We got that out of the way. Now, let's say hypothetically this happens in real life, this situation here, okay? So this is 15 kg, okay, and this is 5 kg. Now if this was in real life, what would happen here? What do you think would happen? So what would happen is, it's because this is 15 kg, obviously this side is going to accelerate down. It's because it's much heavier than 5 kg. Now if this side accelerates down, remember it's going to drag the 5 kg with it to the right. Because if this goes down, obviously this is going to go to the right. Because remember, they're connected by a string, okay? Now if that's true, what happens here is, if this is a meters per second squared going down, therefore this is going to go to the right, a meters per second squared. Listen, I hope so far you're understanding what's going on, okay? So remember, this is 15 kg, this is 5 kg. Obviously 15 kg is way more than 5 kg, so therefore it's going to go down. If it goes down on this side, therefore it's going to go right on this side because the string is connected. You understand? I hope so far you understand what I'm saying. Okay, cool. Let me rub this out. Alright, now we've got that out of the way. Now let's look at the weight. So as I said, if you've watched my previous video, you're going to understand what I'm doing now. If not, go watch that first, come back. Weight is equal to mass times gravity. Okay, now weight is what we always look at, because when we're looking at forces, we're always looking at newtons, okay? Now weight is in the force newtons, okay? The units are newtons, okay? And weight is a force, okay? So I know sometimes in real life, someone's like, oh, what do you weigh? You're like, I weigh 80 kg. That don't actually make sense. You get me? Like, saying you weigh 60 kg, 70 kg, 80 kg, like, scientifically, you get me, as a physicist, because obviously, you know, man, like, Einstein, man told me, fam, you get me? You, man, don't know that, but that's a secret between me and Einstein. But basically, that's actually what it is, okay? So weight actually is in newtons. So you should tell someone, you know, I weigh 170 newtons, 200 newtons, 300 newtons. But anyways, I don't really care about that, but I'm just letting you know. So weight is the force we're looking at. Weight is equal to mass times gravity. And another thing you need to know is gravity is normally given to you, but normally it's 9.81. Sometimes it can be 10. Okay, so it's mass times 9.81 basically, because G is 9.81. Come, little light work thing. Now, this 15 kg obviously has a weight going down. The question is, what is the weight going down? Let me put it in red. So the weight going down is mass times gravity. So mass, we know what the mass is 15. So I'm going to put 15. And then times gravity, so I'm going to leave it as G. Don't put in 9.81 as yet, just leave it as G for now. Okay, calm. we've done this side. Now let's go up here. So remember, it says here, the plane is not smooth, so there's friction. Okay, so therefore, if this is going to the right, friction's pushing to the left, so there's friction to the left. I hope you understand why. So remember, like I said, let's just say you're running. Let's say you're running, yeah, to the right. Why do you get tired? You get tired because on the concrete, there's friction pushing you to the left. You get me? That's why you get tired, fam, because there's friction on the concrete, okay? So therefore, if that's true, and this object is moving to the right, because obviously we know it's moving to the right because it's accelerating to the right, therefore the friction is going to the left, okay? So I hope you understand why the friction is going to the left. Calm, little light work thing. Now, the question is, what is the friction? Now, in the question, they'll always give you something called mu. Okay, so mu is equal to, let's just say, for example, mu is a half. In most cases, mu is always between 0 and 1. Also remember that, don't forget that. Mu is between 0 and 1, don't forget that. Now, so now that we've discovered this, there's an equation we need to know, and it's called FR. Friction is equal to mu times the reaction force. Now, the question is, what is the reaction force, okay? Now, let's find that. Now, back to what I said before. Let's say you're standing in your room. I don't know if I've said this, but let's go through it. Let's say you're standing in your room, okay? Why do you not go through the ground? You don't go through the ground because the concrete is pushing back up equal force. So let's say you weigh like 50 kg, okay, and you're standing in your room. Why aren't you going down? Why aren't you digging down deep to the ground? Reason being is because if you weigh 50 kg, the concrete is pushing back up 50 kg, so you stand in one place. You understand? So this object here is 5g down, okay? But remember, it has a reaction force from the concrete. Now the question is, what is the reaction force? The reaction force is equal to 5g. And the reason being is because up equals down, okay? So this down here is 5g, is going to equal up here, which is reaction force, is going to equal to 5g, okay? So remember, this force is called a reaction. We calculated it to be 5g because we know up equals down, okay? So I'm going to explain that one more time because I need you to fully understand that. Because if you don't understand that, it's going to be jarring. So remember, this object here has a weight of mg, okay? Now the mg, I'm going to put m, which is 5 times g. Okay, cool. This also has a reaction force pushing back up. Otherwise, remember, the 5 kg would have digged down through the ground. Now the question is, what is the reaction force? The reaction force is equal to 5g. Okay, it has to be. Okay, reaction. Because remember, up equals down. Okay, so down was 5g, so therefore up equals 5g. Calm, little light work thing. Alright, we've discovered this, okay? So therefore, this friction is equal to mu r. So mu, I've told you, is a half, okay? So I'm going to put a half here. Times r, the reaction, we've just calculated to be 5g. So I'm going to put 5g here. So therefore, the friction is equal to 5 over 2, which is 2.5. And then the g I'm going to leave there. Calm, little light work thing. Now, what I'm going to do, because I don't want to confuse you, is I'm going to rub out some of these forces. Okay, I'm going to rub out some of these. So I'm going to rub out the 5g. We only used it to find the r. And I'm also going to rub out the r. Okay, let me just rub that out. Give me a second. Alright, cool. So, and I'm also going to replace FR now for 2.5g because we just calculated that. So let me just put 2.5g. Calm, little light work. Now what I'm going to do is I'm going to label this side A. And what I mean is, this thing here A. And I'm going to label this thing here B. So these forces and this whole thing here B. Alright, cool. So now let's say we want to solve for A. Okay. So as I said, if you've watched my first video, it's calm. Okay. But if you haven't, don't worry. I'm going to go through it now. So A, the first thing we need to do is we need to say which way is positive. Now it's accelerating to the right, so therefore right is positive. Okay, that's why it's important to note down which way is accelerating, because you need to let the examiner know. Now, we've said right is positive, okay? Now the equation we use is sum of forces is equal to the mass times the acceleration, okay? Now the sum of the forces, remember we're just looking at A right now, okay? So there's only two forces acting right now, that's T and 2.5g. Now the question is, which one's positive? Is T positive? Yes, it is positive because remember, it's accelerating towards the right, so therefore right is positive, and T is going to the right, so therefore T is positive. So I'm going to put plus T. Now 2.5g is going towards the left. Remember, right is positive, but 2.5g is going towards the left, so therefore 2.5g is negative. So I'm going to put minus 2.5g. Calm! So what we've done now, the sum of the forces, we've done. Cool. That's equal to the mass. So remember, the mass is 5 kg. Times the acceleration. The acceleration is just A. So I'm going to leave it as that. Cool, that's equation 1. T minus 2.5g is equal to 5. So t minus 2.5g is equal to 5a. That's equation 1. All right, cool. Let's look at b now. Okay, so b is only this thing here. Okay, so we're not including this. We're only looking at this here. Okay, so if that's the case, first things first, I say which way is positive. So obviously we know it's accelerating downwards. So I'm going to say down is positive. Okay, down is positive. Cool. Now that I've discovered that light work thing, there's two forces acting. It's this one and it's this one. Now, is 15g positive or negative? It's going to be positive because we know down is positive and 15g is going down, so 15g is positive. So I'm going to get positive 15g, okay? Now t is going up, so t is negative because remember, down is positive, t is going up, so t is negative, so minus t is equal to the mass, which is 15 kg, so 15 times acceleration, we don't know, so that's that. So 15g minus t is equal to 15a. That's equation 2. Okay, so listen, I hope so far you're okay with what I'm doing. So this is equation 1, this is equation 2. What I'm going to do now is I'm going to rub this out so I can solve these simultaneously. So copy this down now, pause the video, copy it down, and then I'll continue. So let me just do that quickly. Let me rub all this out. Give me a second. Alright, cool. I'm there. Don't watch that, I'm nearly there, rude boy. Alright, so now what we've got, remember, yeah, we had equation 1 was t minus 2 point, what was it, 5g equals 5a, yeah? Something like that, I think, yeah. And then the second equation was it was 15g minus t equals 15a. What I'm going to do is I'm just going to replace the 15g and the minus t, so I'm just going to write it as minus t plus 15g is equal to 15a. That's exactly the same thing, remember, because remember we got 15g minus t equals 15a. All I'm doing, I'm just replacing the order, so I'm just writing minus t plus 15g. It's the same thing, okay? You're going to see why I'm doing that now. Alright, now that I've got this, what I'm going to do is I'm going to add these equations. So I'm going to, equation 1 add equation 2, okay? Because when I do that, you get t plus minus t, okay? So that's going to become 0t, okay? So the t's cancel. Then you're going to get minus 2.5g plus 50g, and that should give you 12.5g. Equals 5a, oh, this should be an a here, my bad. 5a plus 15a, that's going to be 20a. So let me just put 20a there. Just put 20a. So now we've got 20a is equal to 12.5g. So all I need to do now is I need to divide both sides from 20 to get rid of that 20. And so therefore, I'm going to get a is equal to 12.5g over 20. Now remember, what you're going to do, you're going to put 12.5 times 9.81 divided by 20. Because remember, g is 9.81. Okay? Now if you do that, you should get a as 6.13. So a is 6.13, okay? So let me try to write that better. So that's 6.13. Calm little light work thing. Now we need to find t. What I'm going to do quickly, give me a sec, let me just rub out this friction thing. Give me a second. Let me rub out this friction thing here. Give me one moment. Alright, cool. Now that I've done that, alright, cool. So what I'm going to do now, I'm going to take equation 1. So this equation here, okay? So equation 1 is t minus 2.5g. Remember, we're trying to find t now. So I'm going to make t the subject. I'm going to take this minus 2.5g to the right-hand side. So t is equal to 5a plus 2.5g. And then now I'm just going to substitute my values in 5a. A we just found is 6.13. So man's going to put 6.13. Plus 2.5. G we know is 9.81. So I'm just going to put 9.81 there. Calm. Now when you put this in your calculator, you should get the tension being... Let me see what I got. What did I get? I think it's 55.17. Or just 55.2. Let's just leave it as 55.2 newtons. Calm. Listen, we're going to look at another question as well, just in case you fully, didn't get this. But let's look at another question now to make sure this gets ingrained in your skull. So let me just rub this all out. Give me a second. Oh, shit. Give me a sec. I just want it to be clean. Okay, I'm nearly there. Give me a second. Come on. Alright, cool. let's say if the question was telling me something like, let's say if this was 8 kg now, okay? Let's say if this was 20 kg, okay? Alright, cool. First things first. Obviously, it says the plane is not smooth, to there's friction, the string is inextensible, blah, 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 blah. So, forget about everything firstly. Let's say to ourselves, okay, if this was a real life situation, this is 20 kg, this is 8 kg, they're connected by a string, okay? What happens? Obviously, it's going to accelerate down from here because 20 kg is much heavier. You get me? So this is going to go down. Now, if this goes down, yeah, this is going to go to the right. You get me? So therefore, this is going to go to the right, 8 meters per second squared. So this is going to accelerate to the right, 8 meters per second squared. This is going to go down 8 meters per second squared, okay? Remember that. Calm. Step 1 done. Now, the string is inextensible, so remember what that means. That means, because this is the pulley here, okay, that's the pulley, what we need to remember now is, fuck it. Give me a sec. Let me drink side. Okay, cool. So now what we need to remember is, this is the pulley, the string is inextensible, so therefore the tension going towards the pulley is equal. Okay? Remember guys, if you don't fully understand what I'm doing right now, go back to my intro to the pulley ones, okay? So that way you fully know what's going on now. Alright, now let's look at for the weight. So remember, weight is equal to mass times gravity. Okay? Weight is equal to mass times gravity. And gravity tends to be 9.81. So now let's look at 20g first. So what's the weight going down? The weight going down is 20 times gravity. 20g. Okay, because the mass is obviously 20 kilograms. Alright, cool. So we're done with that side. Now let's look at this object here. So remember, it's going to the right, so therefore friction's towards the left. Okay? Now remember, this 8 kg is going down 8g here, and it also has a reaction force. Now what is the reaction force equal to? You told me, what is this reaction force equal to? Remember, up equals down, so therefore the reaction force is going to be equal to this 8g here. Okay? So reaction force equal to 8g. Alright, now that we've discovered this, I need to find friction. Friction equals mu r. Now, mu is normally given to you. Let's just say mu is going to equal to, let's just say it's equal to 1 over 4. Okay, if mu is equal to 1 over 4, friction is equal to mu, which is 1 over 4, okay? So I'm going to put 1 over 4 there, times the reaction. The reaction we've just calculated is 8g. Okay, so I'm going to put 8g. So therefore, friction is equal to 8 over 4, which is 2, and then the g, which is just chilling there. Okay, this g. So friction is equal to 2g. Calm. Now that we've done that, I'm gonna replace the FR for 2g now, because we've just calculated that. And then what I'm gonna do is I'm gonna rub out all of this stuff because I don't want to confuse you and I need space. So I'm gonna rub this out. I'm gonna rub out 8g here, this blue thing here. I'm gonna rub out the blue one up here as well. I don't want to confuse us, innit? Oh, I'm gonna have to redraw that the fucking this thing here. So remember, that's 8 meters second squared to the right. And what I'm going to do, let me just rub out this friction thing as well. So we've just calculated that. So obviously you don't need to write it all down. I'm just rubbing it out because I need space. Okay, give me a second. Give me 2 minutes. Don't go anywhere. Give me 2 minutes, man. Relax yourself. Alright, cool. So now, okay, cool. So remember, I'm going to label this A. So this whole thing here is A. And then I'm going to label this side B, okay? So now let's look at A first, okay? Where should I put it? Let's put, you know what, let me just put A here. Let's look at A here, okay? Now remember, talking of A, which way is positive? Obviously it's accelerating to the right, so therefore right is positive. So I'm going to put right is positive. Okay, cool. Once you've discovered that, remember we're looking for the sum of the forces, okay? So now, T, is it positive or negative? You tell me. So remember, we're looking for the sum of the forces. Sum of forces is equal to the mass times the acceleration, okay? So sum of the forces. So T, is it positive or right? Sorry, is it positive or negative? It's going to be positive because remember, it's accelerating to the right, so therefore right is positive, and T is going to the right, so T is positive. So I'm going to put plus T there. Now 2G, is that going to be positive or negative? It's going to be negative because we're accelerating to the right. Right is positive. We've even said right is positive, but 2G is going to the left, so man's going to put minus 2G. So minus 2G. So that's done. Sum of the forces is done. That's equal to the mass. The mass is 8 kg, so I'm going to put 8 times the acceleration, which is just 8. So therefore, T minus 2G is equal to 8A. Alright, cool. Now let's look at B. B is a little light one, yeah? B is a little light thing. So B, if we look at B, there's two forces acting, okay? So we've got the 20G and we've got the T. So which one's positive, which one's negative? Now, obviously, down is positive because it's accelerating down. Okay, so I'm going to put down is positive, okay? Now, if that's the case, 20g is positive because 20g is going down. So I'm going to put 20g. T is negative, so therefore, because remember, t is going up, but down is positive because it's accelerating down. So man's going to put minus t is equal to the mass times the acceleration. So mass is 20, so I'm going to put 20 times acceleration A. Calm! So listen, this is equation 1, this is equation 2, so I'm going to take it to the right hand side here. So we've got equation 1, t minus 2g is equal to AA. And then equation 2, what I'm going to do is I'm going to write minus t first, and then obviously the plus 20g. It doesn't make a difference. Plus 20g is equal to 28. Alright, cool. Now that we've got this clear, all I'm going to do now is I'm going to do equation 1 plus equation 2. Okay? So you're going to get t plus minus t. That's going to become 0t. The t's cancel out. Okay? Minus 2 plus 20. That's going to become 18g. Is equal to 8 plus 20 is going to be 28a. Okay, look how that worked. Now I'm going to make a the subject. So a, if I divide both sides by 28, okay, so a is going to be 18g over 28. So therefore, if you put this into your calculator, you should get a as, I think, 6.3. Obviously, double check all of that. A is 6.3 meters per second squared, okay? Now, once you've got that, I want you to do the rest. I'm not even going to do the rest, okay? So listen, you've got a is equal to 6.3 meters per second squared. So what you need to do now, you can either substitute into equation 1, or you can substitute into equation 2, make t the subject, and then substitute your value of a and g. Okay? Actually, you know what? Let's do that together, because I don't want to do that. That's rude. That's rude. So let me just rub out. Okay, so copy this down. Okay, copy this down. Actually, you know what? Let me just rub out the left-hand side here quickly. Give me a second. Give me a second. Don't go anywhere. All right, cool. I might as well do it with you because, you know, just in case, innit? So that way you know if you've got the answer correct or not. Alright, so let's say we take equation 1. Okay, equation 1 is t minus 2g is equal to AA. I'm going to make t the subject. Minus 2g goes to that side. T is equal to AA plus 2g. Okay, therefore t is 8 times acceleration, which is the 6.3 we've just discovered. So let me just put 6.3. Plus 2 times the gravity, which is 9.81. Okay. And you should get the tension as something like 70 newtons, okay? Calm! Listen, I hope this helped better your understanding. Bear in mind, this is part 1. So don't watch that. More videos coming soon. Love.